Today we'll be adding on to our exponent laws with rational exponents. So if you recall from the last lesson, we used our, this was called our power of a power rule. In order to simplify this expression, so if you have base a raised to some exponent m, and then you raise everything to the exponent of n, then what we found was that we had to multiply the exponents together. Okay? So now in this case, imagine that m itself, so the inside fraction, or inside exponent rather, is itself a fraction. Okay? So if m was equal to 1 over n, then when you raise a to the m to the exponent of n, then that's really raising a to the exponent of 1 over n to the exponent of n. And according to power of a power rule, then we would have to multiply the two exponents together, and 1 over n times n will just give us the exponent of 1. So we end up getting the base a back as our answer. Okay? So what this really tells us is when you have a raised to the exponent of 1 over some number n, okay, where a, so in this expression we have our rational exponent of 1 over n, and we have our base a, which is any real number. Okay, then instead of writing this as a rational exponent 1 over n, then we can rewrite this actually in the radical form nth root of a. So this is how we write it out, like so. Okay, nth root of a. And the answer to this expression is the number that when it's multiplied to itself n times, it gives you the answer of a. Okay, so as an example, let's take 25 to the exponent of 1 over 2. Okay, so this is actually the second root of 25, which is the square root, which is the same thing as just root 25. Okay, so when this number 2, which by the way is called the index, so let me just go back here, this n is the index on a, the radicand. Okay, so when the index is 2, we don't have to write it because it's the default index. Okay, so this 25 to the exponent of half is the same thing as square root of 25, which we know is 5, right? Because we're asking ourselves what number, when multiplied to itself 2 times, okay, so 5 squared, would give you the answer of 25. Okay, so as another example, let's try one more here. If we have, let's say, 8 to the 1/3, okay, then this is really third root or cube root of 8. So I'm asking you what number raised to the exponent of 3 will give you the answer of 8, and that number would be 2. Okay. So a couple of notes about the nth root. If n is an even number, then a has to be positive or 0 in order for you to get an answer that is a real answer. Okay, so in this example we have 4th root of 16. This means what number to the exponent of 4 will give us the answer of 16, and that number, if we know our powers of 2, is 2. 2 to the exponent of 4 will give us 16. Okay, but if we try to do 4th root of negative 16, okay, this means I'm asking you to figure out what number raised to the exponent of 4 gives you a negative answer. Okay, but because this is an even number, okay, that's impossible, right? We can't have an even power of a positive or a negative number to get negative 16. Okay, so we can see that if we try to insert a number, like let's say 2. If we try 2 to the 4, that doesn't equal negative 16, that equals positive 16. And if we try negative 2 to the exponent of 4, that also equals positive 16. It doesn't equal negative 16, right? So neither of those two values work. Okay, so in this case, we would just write no real answers. Okay, so anytime your index is an even number, your radicand has to be greater than or equal to 0. Okay. On the other hand, if the index n is an odd number, then that means your radicand can be any real number in order for you to get an answer. So going back to this example up above, cube root of 8. So we're asking ourselves what number raised to the exponent of 3 gives us 8. That number is 2. Okay. And then if you have cube root of negative 8, then we're asking ourselves what number raised to the exponent of 3 will give us negative 8. Well, the answer in this case would be negative 2 in brackets, right? Negative 2 cubed will give us negative 8. Okay, so when the index is an odd number, then the radicand can be positive or negative, doesn't matter. All right, so I think we already covered this. When the index is 2, that's the default index, right? So the default index of 2 doesn't need to be written. Okay, it's like writing a coefficient of 1 in front of any variable. We know it's there, but we don't need to write it out. Okay, so if you have this example here, 32 to the exponent of 1 over 5, fifth root of 32, it's asking what number, when multiplied by itself 5 times, will give you the answer of 32. So that answer is 2, right? 2 to the exponent of 5 equals 32. Now let's move our page down. Okay, so we have negative 32 to the exponent of 1 over 5. So that will give us our fifth root of negative 32. So we're going to rewrite this as fifth root negative 32. So I'm asking you what base raised to the exponent of 5 will give you the answer of negative 32. And based on the answer from the previous example, you should be able to tell me that the number is negative 2. So negative 2 in brackets to the exponent of to the exponent of 5, sorry, will give you the answer of negative 32. Okay. So in this next example, negative 16 to the exponent of 1 over 4, I want you to notice something. This is not the same as negative 16 in brackets to the exponent of 1 over 4. Okay, brackets are so important because they will tell us whether the answer, or the base in this case, is positive or negative. Okay, so in this situation here, the one that I've written in red, okay, you would have had to write this as fourth root of negative 16, as in what number raised to the exponent of 4 gives you negative 16. And in that case, you would have said no solution, no possible value that will give you no possible positive or negative base raised to the exponent of 4, an even number, will get you a negative answer of 16. Impossible. But in this example 4 here, okay, this is very different because that negative is on the outside. So you have to rewrite this as negative fourth root of 16. That's why the bracket placement is so important, because in this example, you do have an answer for fourth root of 16. Okay? What base raised to the exponent of 4 gives you an answer of 16? That base is 2. And then we are taking that 2 and multiplying it by the negative in front. Okay? So in this example, we do have an answer of negative 2. Okay, so be very, very careful of where you place your brackets. Okay. All right, so when you have a raised to some exponent m over n, m is an integer, n is a natural number, okay, then you're going to end up having, sorry, the placement of the notes are kind of weird, so I can just erase it over here, and I'll just rewrite it in the line over here. So a raised to the exponent of m over n is the same thing as taking the nth root of a raised to the exponent of m, or you can take the nth root of a and then raise that whole thing to the exponent of m. Okay, it doesn't make a difference. So what I mean is, in this first line, this first example here, this would be equivalent to expressing this as a to the exponent of m raised everything to the exponent of 1 over n. Okay, or in the next line, it would be the same as a raised to the exponent of 1 over n, and then raise that to the exponent of m. Okay, it makes no difference whether you apply the exponent of m first or the exponent of 1 over n first. Okay, so let's do some practice. We're going to rewrite each of the following as a power of x, meaning I want you to take the radical form and rewrite using a rational exponent. So in this example, when there is no index, the default index is 2. So this will be x to the exponent of half. Okay. Now in this next example, a couple of ways to do it. I'll show you both. This is really square root of, so you can think of this inside root x as this x to the half from the previous example. So that means I'm going to rewrite this as x to the exponent of half. And then the square root applied to this x to the half is really another exponent of half, like so, which would give you the final answer of x raised to the exponent of 1 over 4. Okay, so if you don't like that method, there is also this one here, where when you have square root x, you can rewrite this as the default index for both is 2. You take those 2's and you multiply them together. So you can rewrite this as fourth root of x. And that will just change into x to the 1 over 4. Same answer. So either method is fine. Either method will always work. It is up to you which one you want to use. Okay. So for the next example C, this 3 is your index n, okay, and this 2, you're going to keep it as your exponent m. So following the rule from the summary box up above, this would mean you would just rewrite this as x to the exponent of 2 over 3. That's it. Okay, so this exponent 2 will become the numerator, and the index 3 will become the denominator. So you always have to follow that rule. Okay. So we have one more example here. So again, whichever way you want to do it is fine. I'll show you both. So this is square root of x to the exponent of 3 over 4. And then that would be x to the 3 over 4 raised to the exponent of half, which gives us, you have to multiply the exponents according to your power of a power rule. So that should give you x to the exponent of 3 over 8 as the final answer. And if you want to do it the other way instead, then that means that here you would take this, multiply the two indices, plural of index, together. So you get 2 times 4, which is 8. And remember, I know that the first index on the outside is 2 because there is no index written. Default is 2. Okay, so it's 8th root of x cubed, which then gives you the answer of x to the exponent of 3 over 8. Okay, either way, same answer. Up to you, whichever one you prefer. Okay, so now we are going to work on evaluating expressions with rational exponents. So there are two different methods. I am going to show you both, and then you can decide which one you prefer. So here in method number 1, you would apply the nth root first, and then afterwards apply the, sorry, not power, it should be exponent. Okay, so if I have 4 to the exponent of 3 over 2, then what I'm going to do is break this down into exponent half and then exponent 3. Okay, then 4 raised to the exponent of half is just square root of 4, and square root of 4 gives us 2, and then 2 cubed gives us 8. Okay, so you're just following this one here. So this 4 raised to the exponent of half is what we have on the inside right there, and then the exponent of half got changed into radical form, root 4, and then root 4 is just 2, and then 2 raised to the exponent of 3, which has been kept on the outside for all of these steps. 2 cubed is 8, final answer. Okay, and if you put this into your calculator, you will get that same answer. Okay. For the next method, you have the application of the exponent first. Sorry, scratch out power, it should be exponent. So apply the exponent of m first, and then you can take the nth root, the index, afterwards. So in this case, we're taking 4 with the exponent of 3 first, which gives us 64. And then the exponent of 1 over 2 changes to square root of 64, and then square root of 64 we know is 8. Okay, in either way you get the same answer, but I would probably recommend method number 1 simply because it's easier to work with smaller numbers. Okay, by taking the nth root first, you end up with a smaller number that you can work with. Okay, and I just want to mention again on the top of this page, I know I've gone over this a few times in class. Remember the difference between, if you have x squared equals 4, then your answer is plus or minus 2. So when you go from square to square root, then you get plus minus answers. Okay, but if you are going with just square root of x, sorry, not square root of x. If you are just going with, oh, sorry, I'm just going to erase this. Okay, if you have just x is equal to square root of 4, okay, remember there is no plus or minus, it's just 2, positive 2. Okay, so when you have, in both of these examples, right, when you take the square root, when you apply the exponent of 1 over 2, it's just square root. Okay, you're not going from x squared to x. So that's why it's only the positive answers that we're giving in both method 1 and method 2. Okay, just wanted to point that out. So let's go over the next few examples. So if you want, you can try some of these on your own first before you hit play on the video, just so that you can try them before you check over the answers. Okay, but I will be using method number 1 for all of these. So what I would do is I would say this is 25 to the exponent of half, and then the exponent of 3. So then this is going to be square root of 25 cubed, which would give me 5 cubed. Final answer, 125. Okay. For number 2, we have 16 to the exponent of half raised to the exponent of 3. So that gives us square root of 16 and then cubed. I'm drawing the brackets like at this step, but if you don't want to, that's fine. And then we have 4 cubed, and that gives us 64 as the answer. Okay, so here we have 16 raised to the exponent of 1 over 4. and then the exponent of 3, which gives us 4th root of 16 raised to the exponent of 3. So 4th root of 16, again, going back to the whole thing about what base raised to the exponent of 4 gives us the answer of 16, or what number multiplied by itself 4 times equals 16. The answer will be 2. Okay, and then we have 2 cubed, which gives us the answer of 8. Okay, in the next example, we have, be careful of your bracket placement, cube root of negative 27. So the negative goes with the 27 as part of the radicand, and then the square is on the outside. So we're asking ourselves, what number raised to the exponent of 3 gives us the answer of negative 27? Okay, and that answer would be negative 3 in brackets. Very, very important. Okay, has to be negative 3 in brackets, because negative 3 in brackets squared is going to give us the answer of positive 9. Whereas if there were no brackets, then the answer would be negative 9. Okay, so especially when it comes to working with exponents, those brackets are so crucial. Okay. All right, next example, we have cube root of 27 raised to the exponent of negative 4. So there's a few different ways to apply the exponent laws here. This is a combination of what we did yesterday with negative exponents and what we're learning today with rational exponents. So I'm going to apply the rational exponent first, and then I'll take care of the negative exponent afterwards. So here you'll have cube root of 27. What number raised to the exponent of 3 equals 27? And that number is 3. So 3 to the exponent of negative 4 is what we're trying to find. Okay. So that means that we are now going to have to apply our negative exponent law from yesterday. Whenever you have a negative exponent, you have to flip your base. So instead of 3, this is going to become 1 over 3. But the exponent is not going to flip. The exponent is just going to drop the negative sign. So that means that we get 1 over 3 raised to the exponent of 4. Okay, so this is really 1 over 3 to the exponent of 4, which is 1 over 81 is your final answer. Okay. All right, let's take a look at number 6. We have negative 81 raised to the exponent of 3 over 2. Remember, the negative is on the outside in this case, so we're taking the square root of 81 and then applying the exponent of 3 and then putting in the negative in front. So then we have square root of 81 is 9 raised to the exponent of 3, and then 9 to the exponent of 3 is really 81 times 9, which is going to give us 729 with the negative in front. Okay, number 7. In this case, look at the placement of the brackets. Okay, brackets around the negative 81. So this is going to give us 4th root of negative 81 cubed. Okay. Going back to the previous page of notes, remember what we said. When the index is an even number, the radicand has to be positive. Okay, so in this case, the index is even, but the radicand is negative. So this means that you're going to have no real solutions. Okay. So basically, if you thought that it was like, let's say negative 3 raised to the exponent of 4, that's not equal to negative 81, right? That's equal to positive 81, because those 4 negatives will cancel each other out. Okay. And remember, you can't write it like this. Negative 3 to the exponent of 4 is not the correct answer, okay? Because the 4th root is being applied to the entire negative 81, okay? So that is not even a possibility. So let's just scratch it out, okay? Alrighty, last example on this page. We have 128 raised to the exponent of negative 4 over 7. So that will give us 7th root of 128 raised to the exponent of negative 4. Okay, so we are looking for some base raised to the exponent of 7 to give us 128. So some of you are thinking, how am I supposed to do this without a calculator? Well, the good news is there's only a few possible numbers that you could try. And really, when you think about this logically, okay, 128 is a pretty small number for it to be raised to the exponent of 7. So that means that the base has to be pretty small as well. And then also 128 is even. So that means that the base has to be even. So your possibilities are really like 2 and 4, and that's it. And if you know your powers of 2, you should know that 2 to the exponent of 5 is 32. 2 to the exponent of 6 would be 64. And then 2 to the exponent of 7 would be double 64, which is 128. So your answer is 2 raised to the exponent of -4. And then, well, anytime we have a negative exponent, we're supposed to take the reciprocal of the base, change that exponent to +4, and that'll give us 1/16 as our final answer. Did this page without any calculators. Okay. Okay, so for this last page of notes, we are solving for x, which today is the base. So yesterday, when x was the unknown exponent, you had to create equal bases on both sides. Today, it's actually going to be a lot easier to solve for x, which in this case is the base. And how are we going to do that? Well, it's very simple. We're just going to raise both sides of the equation by the reciprocal of the exponent that you have. Okay? So, we have this example here already given to you. We're just going to annotate the steps along on the sides. So here we have x to the exponent of 2/3 equals 9. So I want you to give me the answer for x that when we raise it to the exponent of 2/3, or we take the cube root and then raise it to the exponent of 2, should give us the final answer of 9. So what is that for initial number? So to figure out that initial number, we are going to raise both sides by the exponent of the reciprocal of 2/3, which is 3/2. So when we raise both sides to the exponent of 3/2, what you should notice is on your left side, okay, when you apply power of a power rule to these two exponents here, 2/3 times 3/2 is just going to become x to the exponent of 1. So you've essentially isolated for the base x. Okay. Now we are going to end up having square root of 9. Okay, we need to add something to these notes. You need to put down a plus minus. Okay, and the reason why you put down plus minus is because this original numerator is even. Okay, so anytime that happens, you need to put the plus minus down. Okay, think about a simpler example, like if you have x squared to the exponent of 4. Okay, the exponent is even, so that means we had to have two possible answers, positive and -2. It's the same thing here. Okay, when the numerator of the rational exponent is even and you're trying to solve for the unknown base, when you raise both sides to the reciprocal exponent and then you change the rational part, the 1/2 here, into the index square root, you need to make sure you put that plus minus. Okay, so there's two possible answers now. So plus or minus square root of 9 is now going to be raised to the exponent of 3. Okay, so actually in this case we are going to have two possible answers. So one answer is going to be positive 3 cubed, and the other answer is going to be -3 cubed, which is why we are now actually going to have two possible answers, positive and -27. Okay, so let's go over a few examples. And again, anytime you want to pause the video to try an example on your own, please feel free, and then you can start playing the video again to check your answers afterwards. So we have x raised to the exponent of 3 over 4 equals 8. So I'm just going to copy that down again on the next line, leave a little bit of room so that I can show that I want to raise both sides to the exponent of the reciprocal of 3 over 4 is 4 over 3. Okay. And by the way, you should be able to do all of this page without using a calculator again. Try to practice our powers. So here on the left side, 3 over 4 times 4 over 3, according to power of a power rule, we multiply the exponents. That'll give us the exponent of 1, so we've isolated for x, the base. On the right side, when we have 8 raised to the exponent of 4 over 3, that is really cube root of 8 raised to the exponent of 4. Okay, cube root of 8, by now, hopefully you realize it's 2, and then 2 raised to the exponent of 4 is 16. Okay, and in this situation, we don't have to worry about a plus or a minus, okay, because, or rather, like we don't have to worry about two possible answers because the numerator is an odd number. Okay, we only have to worry about the plus minus when the numerator is even. Okay. So let's move on to the next example. X raised to the exponent of 1 over 2 equals 12. So we are going to raise both sides to the reciprocal exponent, which is 2. That gives us 12 squared, 144 is your answer. Okay. And if you're ever unsure as to whether or not you have the correct answer, you can always check by going back to the original equation, substituting your x value, making sure that left side equals right side. Okay. In the next example, when you have number 3, x to the exponent of 0.25, you might not recognize that this is a rational right away. I would recommend that you change this to the exponent of 1 over 4. And now that you see it's 1 over 4, you can simply raise both sides to the reciprocal exponent of 4. So that'll give us x is equal to 81. Okay. Again, you don't have to worry about plus or minus, like two possible answers, because the numerator of the rational exponent is 1, which is an odd number. Okay, so x equals 81 is the only possible correct answer. Okay, next one, we have x raised to the exponent of 5 over 3 equals 32. So this is going to give us, when you raise both sides to the exponent of 3 over 5, let's see what happens. Oops, sorry, I'm just going to erase this and try again here. Okay. So raise both sides to the exponent of 3 over 5. On the left side, your exponent is just 1, so you have x isolated. On your right side, you're going to rewrite this as 5th root of 32 cubed. So rewriting from rational form to radical form. 5th root of 32 is 2. And then 2 cubed is 8. Okay, and again, you don't have to worry about plus minus because the numerator was 5, an odd number, so x equals 8 is the only correct possible answer. Okay, again, if you're not recognizing what the reciprocal should be, simply change the 0.75 to 3 over 4, and now you can raise both sides to the exponent of 4 over 3. Okay. This will give us x on the left side. This will give us cube root of 27 to the exponent of 4 on your right side. Cube root of 27 is going to give us positive 3. Positive 3 raised to the exponent of 4 will give us 81 as our answer. Again, you don't have to worry about plus minus in this case. The numerator of the rational exponent was 3, which is odd. No plus minus. Okay, number 6. We have x raised to the exponent of negative 1/3 equals 2. Same rule applies even if the exponent is negative. Just take the reciprocal, not the negative reciprocal, which some of you remember from grade 9 told us the perpendicular slope of a line. It's not negative reciprocal, just reciprocal. Okay, so if it's a negative number, the reciprocal is still negative. So the reciprocal of negative 1/3 would be negative 3. Okay. That way, when we multiply our two exponents on the left side here together, you'll get just x, right? X raised to the positive 1, which is what we want. Okay. Now, 2 raised to the exponent of negative 3 will give us positive half raised to the exponent of positive 3, which gives us 1/8. And again, you don't have to worry about plus minus in this case. There's only one correct answer because the numerator of the rational exponent was an odd number, 1. Okay, so let's move on to the last few examples here. So for the last row of examples, a couple of additional steps that you might have to take into consideration. So when you look at number 7, instead of applying the exponent of 5/4 to both sides first, you should do something else first. And that first step should be to get rid of that -3 from the left side. Okay, so let's move it over to the right side. So we're going to have x raised to the exponent of 4/5 equals 13 plus 3. So to move the negative 3 over, we have to add 3 to both sides. This gives us x raised to the exponent of 4/5 equals 16. Okay. Now this looks like all of the other problems that we've covered, so we are simply going to raise both sides to the exponent of 5/4. But keeping in mind that because this was an even number for the numerator of the rational exponent, that means that your answer should be plus minus in the end. Okay, so when you take the 4th root of 16, please make sure you put a plus minus in front. Okay, and then you can raise that to the exponent of 5 afterwards. Okay, so that gives us 4th root of 16 is 2, so your two possibilities are positive or negative 2 raised to the exponent of 5. So positive 2 raised to the exponent of 5 is 32. Negative 2 raised to the exponent of 5 would be negative 32. So you get two possible answers for x, plus and minus 32. Okay, anytime your original expression has an even numerator for the rational exponent, okay, you need to do plus minus, get two possible answers in the end. Okay. All right, so here we go. We have x to the exponent of negative 2/3 equals, again, we need to move that 4 over to the right side, so that'll give us 8 minus 4. So x to the negative 2/3 equals 4. We want to keep two things in mind. The first thing is we are going to raise both sides to negative 3/2, because that is the reciprocal of negative 2/3. And the second thing we have to keep in mind is here, this 2, the numerator, it's even. So if it's an even number, that means that we're going to have plus and minus, right? So keeping that in mind, x is equal to plus or minus square root of 4 raised to the exponent of negative 3. So positive and negative square root of 4 would be positive negative 2 raised to the exponent of negative 3. So your answers are 1 over positive or negative 2 raised to the positive 3 according to negative exponent laws. So that gives us positive half raised to the exponent of 3, which is 1/8, and negative half raised to the exponent of 3, which will be negative 1/8. So again, in this situation, you end up with two answers, plus or minus 1/8. Okay. All right, last example here. we have x to the negative 3 over 4 equals 27 over 64. We are going to raise both sides to the exponent of negative 4 over 3. So on our left side, we are going to be left with just x. On our right side, we're going to be left with, we have cube root of 27 over 64 raised to the exponent of negative 4. So according to our exponent rules for distributive property, this is the same thing as cube root of 27 over cube root of 64. Okay, and all of that raised to the exponent of negative 4. So cube root of 27 will be 3. Cube root of 64 will be 4. So 3 over 4 raised to the exponent of negative 4. Now, according to our negative exponent rules, you need to take the 3 over 4 base, flip it to 4 over 3, change your negative exponent to positive 4. And now, according to distributive property, this is 4 to the 4 over 3 to the 4. And that gives us our final answer of 256 over 81. We don't have to worry about plus minus for this situation because our original exponent had an odd numerator. Okay, and again, for something like this that's more involved, I wouldn't necessarily expect you to show me all of the steps. Like you could skip this one, you could go right down to here, and then you could go right down to here, right, or this one and then this one. Okay. Okay, thanks for watching this lesson video. I hope it was useful, and get ready for a formative quiz tomorrow covering lessons 4.1 and 4.2.